Hi guys, welcome to Chain Rule Part 2. This is our second night of chain rule problems, and we're going to look at some more advanced types with some mixtures of trig and a few other things thrown in to kind of give you guys a feeling of what a more difficult type of chain rule question could be. So we're just going to start right off here with this question. Let's just do 2 sine x squared minus 6. Okay, well, if we're going to find the derivative, remember the 2 stays where it is. This becomes cosine. This stays the same. And then you multiply it times the inside. Remember, it's outside, then inside. So the inside derivative would be 2x. And that's all you have to do. Okay, you could move things around. In fact, I tend to write it like this. I take this and I park it in front. You do not have to do this step, but it makes the problem look neater. Okay, so let's try another one. Okay, not bad problem. So we take the derivative. Remember, it's just the 3, then the secant squared. Rewrite the inside, keep it intact, and then multiply it times the derivative of the inside. So this would be 8x minus 6. Okay, not too bad. Now, I want to show you the reason I did this today is I want to show you a few more advanced with the trig functions themselves. I mean, these are advanced, but they're not that difficult. But when they get kind of weird here in a few. Let's take a look at this guy. Okay, this is a deceptive problem because some students think that only the x is being squared, when what really is going on here is this. Yeah, you see the difference? Okay, so what the outside function is the square, and the inside function is the sine. So when we take the derivative, we do 2 in front, rewrite the inside, okay, and then multiply it times the derivative of the inside. Okay, we take the 2, bring it down front, rewriting the inside, subtract 1 from the exponent, and then multiply it times the derivative of the inside. Let's see another example of this. Oh, let's try cosecant, because this can be a tricky one, cubed x. Now remember, this is the same thing as y equals cosecant inside parentheses cubed. Okay, so when we take the derivative, we bring the 3 down front, leave the inside alone, and then multiply it times the derivative of the inside. Well, we know the derivative of cosecant is cosecant x cotangent x. Okay? Not too bad. You just have to be careful and do one layer at a time. So let's do a couple more here and we'll finish this video up. Okay, this is cosine squared of 3x squared. Oh, we've got a triple layer here. So let's take a look at what's happening again. Remember, we rewrite it as this, like so. Okay, so when we take the derivative, remember, deal with the 2. So dy dx is equal to 2. Rewrite the inside in its entirety to the first power. Then take the derivative of the inside, which we all know is sine of 3x squared. Now, hold on. There's a second inside. Take a look at this. So then we have to do 6x as the final derivative. So that really has a third layer that you have to pay attention to. And that will happen frequently with trig functions. When you're taking their derivatives, you could end up having a third layer. So let's look at one more, and we'll call it a day. Okay? Now remember, this is the same thing as y equals, put your parentheses around the cotangent. To the fourth power. Okay, so when you do your derivative, bring the 4 down front, keep the inside, oops, sorry about that. Keep the inside intact. To the third power, then multiply, okay, times the derivative of the inside. Well, we know the derivative of cotangent is negative cosecant squared of this guy. So we rewrite, we're still keeping that one intact. Remember, this is a 3-layer. The 4 is 1 layer, the cotangent is another layer, and this piece is a third layer. So finally, we take the derivative of the inside. And this is about as complex as most of these are going to get. So we get 16x minus 2. Okay, so notice, since there are 3 layers, we should have 3 separate pieces. Notice here, 3 layers, 3 separate pieces. If you look at the previous ones, with 2 layers, 2 pieces. 2 layers, 2 pieces. Okay, so that's kind of an idea to keep yourself on track as you do these. 2 layers, 2 pieces. 2 layers, 2 pieces. You see what I'm saying? Okay. 3 layers, 1, 2, 3 pieces. So you need to pay attention to that. You need to make sure you count how many layers you have throughout the process. And if you do that, you shouldn't have any trouble of finishing this up. Okay? Excellent. Oops, sorry.